Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is OCR November 2023, Paper 1, Foundation Tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends because they might need a helping hand too. Okay, let's get into it. Question 1a. Write down the mathematical name for this solid. Choose from the list of names in the box. Well, any shape that's got a flat base like this and all the corners then go up to a point or an apex, that's a pyramid, isn't it? We call that a pyramid, so that's the word I'm picking. Pyramid. The second one, what shape is this? Well, it's a flat shape, it's a polygon, and it's got 1, 2, 3, 4, 5 sides. 5-sided polygons are called pentagons. Okay, so it's a pentagon. Part C says, on the grid below, sketch a quadrilateral that has these properties. All the angles are equal, the diagonals are not at right angles to each other. Okay. So you've got two choices for all the angles of being equal for a quadrilateral, and that is a square where all the angles are 90 degrees and a rectangle where all the angles are 90 degrees. Okay, so it's either one of those two from that clue there, and the other one, the diagonals are not at right angles to each other. Now if you draw in the diagonals on a square, you'll find that these do cross at right angles, so that means it's not the square. If you look at a rectangle, then you can see that these two angles are not the same, are they? One's obtuse and one's acute. So it's going to be a rectangle. So as long as we can draw a rectangle somewhere in this box, we're going to get the marks for this question. It doesn't have to be any particular size. My pen doesn't seem to want to write on the grid line for some reason. That's very annoying. Let me see if I can move it back on. Okay, actually you don't really need to draw on the grid either. As long as it's a rectangle, it's kind of meeting the criteria for the question and you'll get the mark. Yeah, any rectangle you draw on that box is going to give you the mark. Question 2a. Round 3,648 to the nearest hundred. Okay, so which digit is the hundreds? It's that 6, isn't it? That's where we're going to be rounding off after. So when we round a number, we round off after our given point and we just look at the very next digit and see if it's 5 or more, in which case we raise the score. If it's 4 or less, we let it rest. So this is 4 or less, isn't it? So we're going to let it rest, or round down, in other words. Okay, so when we round down, we keep all the digits in front of the cut line exactly the same. So there's a 3 and a 6 in front of the cut line, so my answer is going to have a 3 and a 6 in it. But then 36 would be a terrible estimate of 3,648, so we need to then pad it out with enough zeros to make it the same size as the original number, same magnitude. Okay, so I'm going to have to add another couple of zeros on the end here. So I've got 3,600, and that's an okay estimate of 3,648, isn't it? Okay, Now I'm going to do the same thing here, round £3.2875 to the nearest penny. So where's the penny in this? Well, you know, pounds and pence. Pence come in hundreds, don't they? So there's 100 pence in a pound. So we need to round off after that second decimal place, the 100th digit. Okay, what's after the 100th digit? This time it's a 7. So 5 or more raise the score this time. So the digits in front of the cut line go up by 1. So rather than having the digits 3 to 8, we're now going to round up and have the digits 3 to 9. The decimal point is in the same place as it always was. It's between that 3 and the 2. So the answer is £3.29. Question 3a. What fraction of this shape is shaded? Well, you can see altogether there are 1, 2, 3, 4, 5 little squares, of which 3 are shaded. So that as a fraction is going to be 3 out of a total of 5 shaded, or 3/5. The diagram below is made up of 100 small squares. Shade 3% of the diagram. Well, a percentage is just simply a fraction over 100. So 3% is the same thing as 3 out of 100. Now, if I've got 100 little squares and I want to shade 3% of them, that means I'm going to have to shade 3 squares then, aren't I? So as long as I shade any 3 squares on this here grid, I'm going to get the marks for this question. Okay, gone over a little bit there, but I'm sure I'll be let off. Okay, so yeah, 3 out of 100 there is 3%. Question 4. Write down the 3 factors of 25. Okay, I normally find my factors in pairs. So 25, I start with 1. 1 goes with 25, so I've got 2 of them already. 2, no. 3, no. 4, no. 5, yeah, 5 goes with 5. So they're my 3 factors. 1, 5, 25. Okay. Write down all the square numbers between 40 and 70. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49. So that's our first number in the range, isn't it? 49. 8 squared, 64. And then 9 squared, that's going to be 81. That's too big again already. So it's just those two, 49 and 64. Question 5. Find the number that is halfway between 4.2 and 6. Okay, 4.2 and 6. Now, to find a halfway point between two numbers, the easiest way is just to average them out. So if I take 4.2 and I add on 6 and then divide it by 2, that should give me the number I want then. Okay, so 4.2 plus 6, that is 10.2. And half of 10.2, that's going to be 5.1 then, isn't it? 5.1. Okay. Question 6. 4 lines meet at a point. This is the point here, look, where they all meet. Work out the size of angle A. Okay, now, one of these angles has been marked, but there's no number next to it. And that's this one here, isn't it? When you see a little square on an angle, it means it's 90% then, doesn't it? Okay. Often students miss that one off by mistake. We know that angles at a point sum to 360 degrees. So if we take those 4 angles then and we add them up, it should be 360. So A, the unknown angle, plus the right angle, which is 90, plus the 39, plus the 125. When I add those all up, that should be equal to 360, because angles at a point sum to 360. So let's just add these up. So 90 plus 39 plus 125, that comes to 215, 245, 254. So A plus 254 is equal to 360. So then taking 254 away from both sides, minus 254, that's going to cancel, leaving you with just A is equal to 106. So that's my value of A, 106. Question 7. A painter mixes red paint and yellow paint in the ratio of 2 to 3. They make a total of 1.5 litres of paint. Work out how much red paint they used. Give your answers in millilitres. Okay? So this is like a dividing by ratio question. We've got 1.5 litres. Now I know that 1 litre is equal to 1,000 millilitres. So 1.5 litres, that's going to be 1,500 millilitres. That's what I'm dividing into this ratio. Now I've got the ratio of 2 to 3, and I know that 2 plus 3 is equal to 5. So that means if I've got 2 shares and 3 shares, then altogether I've got 5 shares. Now what's the value of each of those shares? If I take 1,500 and I divide it by 5, that's going to equal 300, isn't it? Okay, 1,500 divided by 5. That means the value of each share must be 300. So if I take this ratio 2 to 3 and I scale up by a factor of 300, 2 times 300 is 600, and 3 times 300, that is 900. And you can see that 600 and 900 do add together to give me 1,500. That's usually a good check to do. Now what do we need to give as our answer? How much red paint? So it was red paint to yellow paint, wasn't it? So the left hand side is red, so that's going to be, my answer is going to be that one. It's going to be 600 millilitres then, isn't it? 600 millilitres. Question 8. The diagram shows a cuboid with dimensions 12 centimetres, 5 centimetres and a mystery x centimetres. Okay, so we don't know that length there, so we've put in an x to represent it. We do know the volume of the cuboid though. We know that the volume of this cuboid is 240 cubic centimetres. So that's how much space is in that cuboid. And we also know the formula for finding the volume of a cuboid, don't we? It's volume is equal to length times width times height. Now here we know most of those things. We know the volume. The volume is 240. They give it us in the question. We know the height. Height is 5, look. So that's going to be times 5. We know the length and the width. The length is 12 and the width, well, the width is the thing we're trying to find. That's the x, isn't it? So I've got x times 12 times 5, and that's equal to 240. Well, 12 times 5, that's 60, isn't it? So I've got 60x on the right-hand side and 240 on the left. Now, if I then just divide both sides by 60, then that will cancel, leaving me with x over there, look. And then 60 is into 240, that goes 4 times. Okay, so that tells me then that the width of our box, or our length of our box, needs to be 4, because 4 times 12 times 5 is going to be 240. Question 9. Heidi and Yoshi compete in the same car race. Heidi completes the race in 6 hours. Heidi's average speed was 50 miles per hour. Yoshi's average speed was 48 miles per hour. Calculate how long it took Yoshi to complete the race. Give your answer in hours and minutes. Okay, so this is a distance, speed, time question. So I'm going to use the DST triangle to help me here. Distance, speed, time. Okay, what do I know? Do I know distance, speed, or time? Is it given in the question? Normally we're given 2 out of 3 of these things. What have we been given here? So we know that Heidi completes the race in 6 hours. Okay, so for Heidi, we know that she completed the race in 6 hours, so the time is 6. Okay, her average speed was 50 miles per hour, so speed there, look, is 50 mph. What we don't know is the distance that the race took place over. So I think the first thing I want to find is the distance from the race from Heidi's information. So covering up the thing I want to find, that's the D. That tells me that distance equals speed times time. So let's write that down. Distance equals speed times time. Okay, so the speed for Heidi was 50. The time was 6 hours, and 50 times 6, that's 300, isn't it? So that means, well, if it's in miles per hour and hours, then I multiply it together, I'm going to get miles then, aren't I? Okay, so the total distance for the race was 300 miles. Now let's switch over to Yoshi. Again, distance, speed, time triangle for him, or her, I don't know what Yoshi is. what have we got here? Distance, speed, time. Now, it's the same circuit or the same race, so the distance is going to be the same, isn't it? So that distance there is my distance. So that's going to be 300 miles. Now, we've been given his speed in the question. Yoshi's average speed was 48 miles per hour. So I know that this speed here is going to be 48 mph. Calculate how long it took Yoshi to complete the race. So that's what we're trying to find, isn't it? We're trying to find time taken for Yoshi to do the race. Okay, that's what we want to find. Okay, so covering up time this time, then I can see that time equals distance over speed. Time equals distance divided by speed. What's that then? So distance is 300 and speed is 48. Now if I type that into my calculator, 300 divided by 48, I'm going to get 6 and a quarter, aren't I? Or 6.25. Now I want that in hours and minutes though. Now it's actually quite easy to turn that into hours and minutes using what's called sexagesimal mode on your calculator. So if you go to Format and go right down to the bottom of List, you'll find one called sexagesimal. So press that, and you can see it converts your time into 6 hours, 15 minutes and 0 seconds. So that's equal to 6 hours and 15 minutes altogether. Question 10. Alex and Emma use this recipe to make scones. The recipe shows the ingredients needed to make 16 scones, or scones if you prefer. Alex makes 24 scones. He uses a tablespoon to measure the amount of milk he needs. The size of the tablespoon is 15 milliliters. How many tablespoons of milk should Alex use to make 24 scones or scones? So I've got a recipe here for 16 scones. And for 16 scones, we need, how much tablespoons of milk do we need? We need 70 milliliters of milk. Okay, so 16 scones goes with 70 milliliters. So scones to milk is 16 to 70. Okay, so then what I want to do is I want to get this up to 24 scones. Okay. Now 16 doesn't go neatly into 24, but if I halved it first and got 8 scones, so if I took 16 and I divided it by 2, I would get the recipe for 8 scones, and then if I took the recipe for 8 scones and I times it by 3, I would get the recipe for 24 scones. So doing the same thing to the other side, if I take 70 and I divide it by 2, then 8 scones I know is going to take 35 milliliters of milk, and then that amount, if I then times that by 3 like I did on the other side, then I know that 3 lots of 35 or 105 milliliters of milk is what's required for 24 scones. Okay, so I need 105 milliliters of milk needed. Now what is that in tablespoons? Now I'm told here that a tablespoon of milk is 15 milliliters of milk. So if I want to know how many tablespoons, I need to take 105 and divide it by 15. So how many 15s into 105? 15 30 is 2, so 60 90 would be 6. I think it's 7, isn't it? 7 times 15 is 105. So it goes in 7 times. I'm going to need 7 tablespoons. Okay. Right. Part B says Emma has 1 kilo of flour and 240 grams of sultanas. She has lots of all the other ingredients. Work out the maximum number of scones or scones that Emma can make. You must show your working. Okay, so which is going to be the limiting factor here? Emma has 1 kilo of flour and 240 grams of sultanas. Now in the original recipe, look, it needed 80 grams of sultanas to make 16. So 80 fits into 243 times. So this is like enough sultanas for 3 lots of 16 scones there, isn't it? So you've got 3 lots of 16 scones there. Maybe I'll just show that in a calculation. Should really show my method. So 240 divided by 80 is equal to 3. Okay, so yeah, it goes in 3 times. So I'm going to have 3 lots of 16 scones I can make with that. What about the kilo of flour? That's going to be more of a limiting factor here. With the flour, I've got 1,000 grams, which goes into a kilogram. And then how many times does 400 fit into that? Well, 1,000 divided by 400, that's 2.5, isn't it? So I could make 2.5 lots of 16 scones for that one. So that's going to be the more limiting factor, isn't it? Because I've got plenty of sultanas, but I've only got enough flour to make 2.5 lots of our recipe. Okay, so I'm going to do 2.5 times 16, 2 lots of 16 and half of 16. So 16, 32 and half of 16 is 8. That's going to be 40, isn't it? 2.5 times 16 is 40 scones. Well, that's quite a lot of scones, isn't it? 40 scones is the answer. Okay, and that's the maximum we can make, because after that we run out of flour. Question 11. 140 people asked if they have a bicycle, B, or a car, C. 22 people only have a bicycle. 72 people only have a car. 29 people have both a bicycle and a car. Show this information on a Venn diagram. Okay, so how can this information fit in? Okay, now normally I like to start in the middle, because that's easiest to do with these things. Start in the middle. So which one is the middle? 29 people have both a bicycle and a car. So I'm pretty confident that the number 29 goes in that middle bit there. Okay. Now it says 22 people only have a bicycle. So that is the people in this part of the diagram. Only have a bicycle. That means they have a bicycle and they don't have a car. Okay. So in that part there, look, that is going to be 22. So I'm going to write 22 in there. And then it says here that 72 people only have a car. So again, it's the bits inside the C, but outside the B that they're talking about there. Only have a car and not a bicycle, basically. And then that is another 72 people. Okay. Now, finally, we're not quite done here, because it also says there are 140 people altogether. And so far, I've only got 22 plus 29 plus 72 people on my diagram, which does not add up to 140. Okay, so the number of people that go outside the two circles but inside here is going to be given by 140 minus those three other regions. So the 22 plus the 29 plus the 72 taken away from 140 then, isn't it? So what is 22 plus 29 plus 72? 72 and 22, that's 94. Add on the 29, that's 123, I believe. 1, 2, 3. So 140 minus 123, that's going to be equal to 17. Okay, so there are 17 people that have neither a bicycle nor a car. So let's answer the questions now then. So how many people do not have a bicycle or a car? Well, that's those 17 people we were just talking about. So that is 17. Write your answer in the correct place on the Venn diagram. Well, I already did that. And then one of the 140 people is chosen at random. Work out the probability that they have a car. Okay, well, the probability that they have a car are all the people inside the circle labeled C, isn't it? So the probability of car, that's going to be the 72 people had a car only. They're the ones in the blue bit. We have to also include the 29 people who have both a car and a bicycle, and that is out of a total of 140 people we could pick from. So 72 plus 29, what's that, 101? 101 over 140, that's our probability then, isn't it? So 101 over 140. Okay. Question 12, the cost to hire a motorhome are shown below. You've got a motorhome hire, first day is £130, each extra day is another £90 on top of that, and each mile travelled is 60p. Finley hired a motorhome and travelled 560 miles. The total cost of the hire of the motorhome was £916. Calculate how many days Finley hired the motorhome for. You must show your working. Okay, so we know that the total cost for Finley is going to be the first day charge, which is £130. It's going to be that amount. Okay, and then it's going to be 90 times the number of days. Now, I don't know the number of days. I'm just going to use a bit of algebra to do that and say 90d, where d is the number of days. So I later find out that d is 5, then it means 90 times 5, doesn't it? Or whatever that is. Okay, so £130 plus 90d, where d is the number of days. And then we've got to put on the mileage charge. So he's got 560 miles. Okay, at 60p a mile, isn't it? Okay, so it's going to be another 560 times 60p, which is 0.60, isn't it? Or 0.6 if you prefer. Okay, and we know he was charged £916. So 916 is equal to all these things added up, isn't it? So let's just tidy up what we've got. We've got the 130 plus the 90d. What is 560 times 0.6? So 560 times 0.6. That comes out to be £336. Okay. So adding our two amounts together, the 336 and the 130, that comes to 90d plus £466, and that is equal to 916. Okay. Now we want to know the number of days, so let us subtract 466 from both sides to try and get d on its own. Okay, so that's going to cancel, leaving me with 90d on this side. On the other side, 916 take away 466, that is 450. Okay, so I've got 90d equals 450. Now what I'm going to do is I'm going to divide both sides by 90. Okay, so that's going to cancel. So d is equal to 450 divided by 90. So let's just cancel off the zeros. 45 divided by 9. 9 goes into 45 5 times. Okay, so that means that he must have been traveling for 5 days. Now just take a little bit of care here, because what we've just worked out is d, which came from here, look, and that was the each extra day. Okay, so if there were 5 extra days, then the total number of days is going to be the first day, 1 day, plus the 5 extra days. So it's going to be 1 plus 5, isn't it? It's going to be my 5 extra days plus my first day, giving me 6 days altogether. So it's actually 6 days, not 5. Question 13. A climber is in a competition. Here are the scores after 2 events. In event 1, 24 out of 30 points were scored. Event 2 was 32 out of 38. Event 3, we don't know what the score is yet, but we know it was out of 52 points. Yeah, and it says it down here as well. The event 3 is out of 52 points. The climber's overall score is found by adding the 3 scores together. Find the score the climber needs in event 3 to achieve 85% of the total points. Okay. Well, what is the total points? Total points, it's going to be those 3 amounts added together. 30 plus 38 plus 52. Now, 38 and 52 adds up to 8 onto 52 is 60. Add the 30 is 90. And then add on the 30, that's 120 then. So it's out of 120 points. Now, if he wants to have 85% of that, we need to work out 85% of 120. Okay, so I'm just going to draw my triangle for probability. Final, original, multiplier. What we've got here then. Okay, so this is my original. So we've got 120, of which we are trying to find 85% of. Multiplier, we want 85%. So the multiplier is going to be that as a decimal. So the multiplier is going to be 0.85, which is 85% as a decimal. And what we want to do is find out the final. How much is 85% of 120? Okay, so how do I do that? Well, cover up the f. F equals O times n. The final is equal to the original times the multiplier. The original is 120. The multiplier is 0.85. So multiply those together. 120 times by 0.85, that comes to 102. So it's going to need 102 marks in total, okay? Now he's already scored 24 and 32, so his score so far is those two scores added together, the 24 plus the 32, and that comes to 56, doesn't it? So he scored 56 points already, and he needs to get up to 102, okay? So points needed, it's going to be the 102 points he needs minus the 56 points he's already got. So what's that then? 102 minus 56, that's 46. So he's going to have to do pretty well in the last round then, 46 out of 52, in order to achieve that 85% amount he's looking for. So that is 46. Question 14, for each graph below, sketch its possible equation from the list. Okay, so I've got y equals minus 3. Now y is equal to a number is a horizontal line going through that number. So y equals minus 3 is going to be a straight line like that. That's not one of my lines. Y is equal to x, that is a diagonal line going through the origin like that. That looks like one of mine. I think that one's going to be B. C, y equals x plus 1, that is a straight line. It's going up diagonally, but it's passing through the y-intercept of 1, isn't it? This is the y-intercept here. So it looks like B, but slightly taller, or slightly further up the axes. Y equals x squared. This is a quadratic equation, and these look like a parabola, like a U shape. That doesn't look like my graph. X equals minus 3. That is a vertical line passing through minus 3 like that. So x is equal to number is always a vertical line. And then finally I've got y equals x cubed. Now that is a cubic curve, and that does have this shape, this kind of S shape. It starts low and ends high and has a kind of wobble in the middle. Yeah, and that is then the one we want, isn't it? Now, you need to kind of know the basic shapes of these graphs. If you don't know what these graphs look like, there's really no way of answering this question. And it's just really a knowledge question. So, kind of sketch them, sketch what a typical quadratic, what a typical cubic, what a typical linear equation looks like. And yeah, have those in the back of your mind. So you can answer questions like this. Question 15, here are two functions. Function A, we take the input, we multiply it by 5, we add 4 and we get the output. Function B, we've got the input, we times it by some value P, we don't know yet, and then we subtract 8 and we get the output. And it says when the input of each function is 6, the output of function A is equal to the output of function B. Work out the value of P in the function B. Okay, so for each one of these, we're going to input 6. What we're going to get out the other end? Well, in the first one, I'm going to take 6, I'm going to times it by 5. So that's going to give me 30. And then if I add 4 to it, I'm going to get 34 out the other end, aren't I? Okay, so that one's fairly easy. Now, if I do the same thing here, if I take 6 and I times it by P, what's 6 times P? Well, that is algebraically 6P. And then if I subtract 8, I'm going to get 6p minus 8 out the other end. Now we're told in the question that these two things must be equal to each other when you put in 6. So those two things are equal. So that means I can form an equation, 6p minus 8 is equal to 34. Okay, so if they're equal, I can make an equation about them like that. Then I just need to solve this equation to find the value of p. Okay. Now at the moment I've got P, it's multiplied by 6 and I'm subtracting 8. So rearranging that, I'm going to have to do kind of like the opposite to it. So I'm going to have to add 8 to both sides to start off with. They cancel, leaving me with 6p on this side. And 34 plus 8, that is equal to 42. Okay, almost there. Next step, just divide both sides by 6. Then that's going to cancel there, look, leaving you with just P on the left, and 6 is into 42 go 7 times. So what is the value of P? P is equal to 7. So when I times 6 by 7, I'll get 42, and then when I subtract 8, I'm going to get 34, which is the same as the other output. Question 16a, multiply out 5a lots of 2 minus a. Okay, So when we've got a bracket like this with something on the outside, then what we do is we multiply everything on the inside of the bracket with that value that's on the outside. So first up, I've got 5a times 2. Well, 2 lots of 5a is going to be 5a and 5a, which is 10a. And 5a times minus a, I'm going to have a minus in between. A times a is a squared. So 5a times a is 5a squared. So that's what my answer is, 10a minus 5a squared. Part B says solve 5x plus 9 is greater than 12. Now these inequalities solve pretty much the same way as equations as long as you keep everything positive. So if I take 9 away from both sides here, just like I would with an equation, they'll cancel, leaving me with 5x is greater than 12 take away 9, that's 3. And then to get x by itself, I'm going to divide both sides by 5. X is greater than 3 divided by 5. That's my answer. Okay, now I could work that out as a decimal, but there's no need. Fractions are perfectly fine. So I'm just going to write down x is greater than 3/5. Finally, I've got solve by factorising x squared plus 7x plus 12. Okay, now I want to factorise this. It's going to go into two brackets like that, equal to 0. Now, if it's got an x squared at the front, then I must get that by multiplying two x's together, like that, x and x. Now, it's got a 12 at the back there, and I get that by multiplying these two numbers together in the brackets. So, if I can work out what the factor pairs of 12 are, which are 1 and 12, 2 and 6, 3 and 4, then my two numbers there and there must be one of those pairs of numbers because they multiply together to give you 12. But the numbers also add together to give you 7, and there's only one pair of these numbers that adds up to 7, and it's that pair there, isn't it? 3 plus 4 is 7. Okay, so that tells me then that one of these numbers must be 3, and one of these numbers must be 4, so they multiply together to give me 12, and add together to give me 7. Okay, right, now I've got them factorized into two brackets. Now, when you've got two things and you multiply them together and you get 0, it must be that one of the things was 0 to start with. That's the only way that can happen. So if x plus 3 times x plus 4 is 0, that means that the x plus 3 bracket must have been 0 to start with, or it could have been that the x plus 4 bracket was equal to 0 to start with. Now, if x plus 3 is 0, that means that x is minus 3, because minus 3 plus 3 is 0. And if x plus 4 is 0, then that must mean that x was minus 4, because minus 4 plus 4 is 0. So they're my two solutions then. X equals minus 3, x equals minus 4. A prime number is a whole number that has exactly two factors. Question A says, explain why 1 is not a prime number. Well, it comes from the definition, doesn't it? A prime number has exactly two factors, and what are the factors of 1? There's 1. So it doesn't have two factors, so it can't be prime. So 1 only has one factor and not 2. Okay, so it's got one factor and therefore it is not prime. A and B are prime numbers. Write down the 6 factors of a squared b. Okay, well, if you think about factor pairs, normally, if I wanted to write the factor pairs of 12, I'd write 12 at the top and I'd write them down in pairs. So 1 goes with 12, 2 goes with 6, 3 goes with 4. Now, if I did the same thing with a squared b, then 1 would go with a squared b, wasn't it? Because 1 times a squared b is a squared b. And then I need to find some other factors that I can put on the left which pair up with something on the right. So when I multiply it together, I'm going to get a squared b. Okay, so what I'm going to do is I'm going to take the a out and think, well, a times ab is a squared b. And I could also take the b out, so b times a squared is a squared b. And the other factor I could take out, I guess, is a squared. If I could take a squared out and then times it by b. But that's just, oh, I've already got that one, haven't I? I've got that one from before. So that one isn't going to work. So it's those 6 then, isn't it? So I've got 1 and a squared b, a, b, b, and a squared. The table shows the results for sports club's A team. So I've got the results, which are either a win, draw and loss and the number of times that occurred. And I now need to complete and label a pie chart to show these results. Okay, so these are out of 40, but pie charts are out of 360. So when you're drawing the pie chart, the first thing you need to do is work out what the ratio is really between those two numbers. Okay, so the ratio of 40 to 360, both sides divide by 40, don't they? Divide by 40, and that's going to give me 1, 2, 40s into 360. That's going to be 9 times, isn't it? So that means this was the number of results, wasn't it? And this is the angle. So that means for every one result, we're going to be using 9 degrees. So in my table, if I write the angle up here, then what I'm going to have to do is I'm going to have to multiply each one of these by 9 then to find the angle. Okay, so what is 18 times 9? 18 times 9, that comes to 162. 10 times 9 is 90. 12 times 9, that is, well, it's 108, isn't it? And you should notice that they actually all add up to 360 as expected. Okay, so now it's just a matter of drawing those angles on the pie chart. Now one line has already been given, so I'm going to use that as my starting point. I'm going to lay my protractor along that line with the center of the protractor in the center of my circle. And then I'm going to count round to 162 for the first angle. So that comes round to here, I think. So make a mark there, and then I can draw that line in. Okay, so that's going to be my wins. And then draw is 90 degrees, so I'm going to have to then put my protractor back down where I left off and then carry on around then, aren't I? So put in my protractor there. I can then measure an angle of 90 degrees and make a mark. Okay, and then lay my ruler out, I can then join that up. Okay, and then that last line then divides my shape into win, draw, and loss now, doesn't it? So the 90-degree angle was draw, and lose is 108 degrees, which kind of draws itself. Okay, so when you're drawing a pie chart, the most important thing is getting those angles right at the top. So most of the marks will come from this table part up here, working out the 3 angles. And then you'll get a mark or 2 for actually drawing it. Don't forget to label your pie chart at the end. If you don't put the win, draw and loss in there, then you're going to lose a mark for sure. Part B says here are the results from the sports clubs B and C team. The C team manager says that the pie chart shows that the C team won more games than the B team. Referring to the pie charts, explain why the C team manager may not be correct. Okay, well you can see that the C team proportionally won more games, but you don't know how many games the B and the C team played. Okay, so C team won more than a quarter of the games, but if it played fewer games, then that more of a quarter might be less than a quarter of the other one. Okay, so we only know that the C team won proportionally more games, but we don't know how many games the B and C team played. B team could have played many more games. I always write too much of these sort of things. You can probably get away with saying B team might have played more games. I don't know. Okay, but I like to be thorough. The graph shows Taylor's journey from home to an airport. During the journey, Taylor stops for petrol. Okay, so we can see this journey coming home. So He starts off going at one speed, he speeds up a little bit, he stops a bit, and then he goes again. So for how long did Taylor stop for petrol? Well, when he stops, he's not moving anymore, is he? So his distance is going to be unchanged for that period. So the period where he stops is this section here. So reading down to the axes from the ends of those two lines, you can see that he stopped after 20 minutes and then started again 2 little divisions later, which is what? So on this scale, I've got 1, 2, 3, 4, 5 little squares between 20 and 30. That spans 10 units, and I've got 5 divisions, so each division must be 10 divided by 5, must be 2. So that means that number there must be 24, and so he must have been stopped for 4 minutes then, so that is 4 minutes. Taylor drives the same route back home from the airport at an average speed of 45 kilometers per hour. Taylor leaves the airport at 10 in the evening, 2200 hours. Work out the time that Taylor arrives home. Okay, so I'm going to draw another triangle for this one. This time we've got distance, speed, time. Distance, speed, time. So what's D, what's S, what's T for these then? Okay, so I know the average speed. It's here, look. Speed is 45 kilometers an hour, so that's going to go here. 45 kilometers per hour. I know the leaving time. I want to know the arrival time. So it looks like it's the time I'm trying to find here. Do I know the distance? Yeah, I can take the distance from the chart, can't I? Because he's going the same route back. So however far he went in the journey there is the same amount of distance he has to travel on the way back. So what's that then? So just reading across from the top of my chart there, you can see that that reached a height of 4 little divisions up from 40. So that is 48 up there, isn't it? Okay, so he must have traveled 48 kilometers on the way there. So he must have traveled 48 kilometers on the way back. Okay, so I got that from over here, look. Okay, so now I just need to cover up the thing in the triangle that I'm trying to find, which is T, and then write out the formula for that then. So the time is equal to the distance traveled, total distance traveled, divided by average speed. So in that case, in this case here, that's 48 kilometers divided by 45 kilometers per hour. What does that come out to be? So 48 divided by 45, that comes out to be a bit 1 and a bit, doesn't it? It's a fraction. Now I want this as a time. Now there is a feature on your calculator to show this in sexagesimal mode. So if you press the format key, go down to sexagesimal, then that will rewrite it as 1 hour, 4 minutes and 0 seconds. Okay, so that's 1 hour, 4 minutes and 0 seconds. Okay, so what's 1 hour and 4 minutes after 2200 hours? So 2200 plus 1 hour and 4 minutes, that comes to 2304. So he must have arrived home at 2304 then. Okay. Write an expression for weight in grams of an object weighing X kilograms. Well, to go from kilograms to grams, you need to work out, well, you have to multiply it by 1,000, don't you? So if X is the weight in kilograms, then in grams, it's going to be 1,000 X. Okay? Write an expression for the area in meters squared of a garden with an area of y centimeters squared. Now converting from centimeters into meters, you're going to have to this time divide by 100, aren't you? Because 1 meter is 100 centimeters, but this isn't normal centimeters, normal meters, it's meters squared. So 1 meter squared is 1 meter times 1 meter, which is 100 centimeters times 100 centimeters. That's 10,000 centimeters squared then, isn't it? 100 times 100. So that means if I want to convert y centimeters squared into y meters squared, I'm going to have to divide through by that bigger number. So it's going to be y over 10,000. Okay? Question 21a. A student is using trigonometry to work out an angle B in a right angle triangle. They tell the teacher that the sine of B is equal to 5 over 4. Explain why the student must be wrong. Well, pretty obviously, because when you're working out the sine, you are working out the opposite over the hypotenuse, isn't it? So sine theta is equal to the opposite side divided by the hypotenuse. Okay? Now in a triangle, what is the hypotenuse? What is the hypotenuse? Hypotenuse is always the longest side, isn't it? Okay, that's what the hypotenuse is. It's that side opposite the right angle. Now, depending on where I mark the angle, the opposite could be one of the other two sides. Let's say I put theta here, then this is the opposite over here. Okay, but the sine of the angle is going to be the opposite side divided by the hypotenuse side. Now, we know something about the hypotenuse. It's always the longest side. Okay, that means that h is always going to be bigger than O, and that means that that sign could not happen because in here, look, I've got the numerator 5, which is bigger than the denominator 4. And if that was true in this triangle, that would mean that the opposite side was longer than the hypotenuse, which is a contradiction, isn't it? Because the hypotenuse has to be the longest side. Okay, so that is why I know, or the teacher must know, that this is wrong. Okay, the numerator is bigger than the denominator, which is impossible. Now, I don't really need to go into any more detail than that because it's only a 1-mark question. I mean, I could go on and say, well, you know, the hype has to be bigger than the op, but it's a 1-mark question. So I think if I just write down the numerator is bigger than the denominator, that's how I can tell it's wrong. I think that's acceptable for this question. Part B says, here is a right angle triangle, work out the value of x. Okay, so when we're trying to solve trigonometric problems like this, the first thing I recommend you do is label up your sides. Now, I just said earlier the hypotenuse is the longest side, so I always start labeling up with that one first, so that's my h there. Okay, and then I just need to work out what the other two angles are. Now, the other two are always labeled relative to the given angle, and the given angle is this one. It's this x up here. It's the only one that's being marked, isn't it? Now, one of the sides is going to be opposite that angle, so this is going to be the opposite, and one of the sides is going to be joining on or adjacent to that angle, and that's going to be my adjacent. Okay, so in this particular problem, I've been given the adjacent, it's 24. I've been given the hypotenuse, which is 20. I've not been given the opposite, and I'm not really interested in the opposite. Don't want it, don't need it. That one I don't need. All right, so then writing down the mnemonic SOHCAHTOA, which is our way of remembering the sine, cosine, tangent formula, that means that I can get rid of all the ones that have got an O in it because I know I don't want O. So SOT is out because it's got an O in it. TOA is out because it's got an O in it. Must be that it's the cosine here. C equals A over H. Okay, so let's write out the proper formula for cosine. Cos theta is equal to the adjacent divided by the hypotenuse. Okay, subbing in what we know from the question, cos theta is the placeholder for the angle, and this question, the angle is x. I'm going to replace theta with x. The adjacent we were told was 24. Okay, it's the green one. The hypotenuse we said was 40. That's the blue one. So that's going to be 24 over 40. So I've got cos x equals 24 over 40, but I want to know the value of x, not the value of cos x. That means I need to get the value of x back from the value of cos x. Now, when you've got a function of x here and you want x, you have to do the opposite of that function to get your x back. So for instance, if I had x squared is equal to, I don't know, 16 and I wanted x back, I would have to do the opposite of squaring to both sides. So square root of x squared would be x, square root of 16 would be 4. So I could get my value of x back that way. Okay. Now the same is true here with cos x. we need to do the opposite of cos x to both sides, so we can kind of undo the function cos that's been applied to x. So if I apply the opposite to cos x, then I'm going to get x back. So I need to apply the opposite of cos x to the fraction on the other side if I'm going to do the same thing to both sides. Now we call the opposite of cos the inverse cosine of x, and it's written like that, cos to the minus 1. So x equals cos to the minus 1 of 24 over 40. Now we can just find that out by tapping it straight into the calculator. So you've got the shift if you want the inverse cosine, you have to press shift first. So shift and then the cos button. You'll see you'll get cos to the minus 1, and then we're going to do 24 divided by 40, or 24 over 40 is a fraction, and then that's going to give me 53.1 to one decimal place. So that's going to be my answer, 53.1. So x is 53.1. Question 22. On a bus route, there is a set of traffic lights and a level crossing. The probability that the bus stops at the traffic lights is 0.7. The probability that the bus stops at the level crossing is 0.2. Use the information to complete the tree diagram. Okay, so we've got a number already on here. We've got the probability of it stopping at the traffic light already marked here, 0.7. Now, all the branches at any point on your tree diagram need to sum to 1, because it has to go one down one side of the branch or the other. So all the outcomes need to add up to 1. So if that's 0.7 there, then this must be 1 minus 0.7, or 0.3 for does not stop. So the probability it stops is 0.7, so the probability it doesn't stop is 0.3. Now we're also given the probability for stopping at the level crossing. So stopping at the level crossing is going to be 0.2, and if the probability of stopping is 0.2, then the probability of not stopping, does not stop, is going to have to be 1 minus 0.2, which is 0.8. Okay? Now this is independent probability. The outcome, the probability of it stopping at the lights has got nothing to do with the probability of it stopping at the crossing. So these are going to be the same down here as well. So I'm going to get 0.2 and 0.8 for the probability of stops and does not stop. Okay? So that's my 3 marks. And then it says find the probability that the bus stops at either the traffic lights or the level crossing, but not both. Okay? So which outcomes are either or? So we could have it stopping at the lights and not stopping at the level crossing, or we could have it not stopping at the lights but stopping at the zebra crossing. It's those two routes. Okay, so what's the probability of stop doesn't stop? I put a little bar on the top of a letter to show that it isn't the opposite of what that letter should represent. So if S is stops, then S bar is going to be not stops. So what's the probability of stop not stop? It's the blue route, so all the numbers on the blue route multiplied together. So 0.7 times 0.8, that's going to be 0.56. And then the pink route is the probability of not stop stop. And that's going to be the numbers along the pink route all multiplied together. So that's going to be 0.3 times 0.2, which is 0.06. Okay? So then the probability of stops only once is going to be those two outcomes added up. It's going to be probability of stop not stop plus the probability of not stop stop, which is the pink one. So pink route plus blue route, and that comes to 0.56 plus 0.06, that comes to 0.62 then, 0.62. Question 23a, the measurements in centimetres of two triangles are shown in the table. So I've got triangle 1, which has got sides 2.5, 3.2 and 4, and triangle 2, which has got sides 7, 8.96 and 11.2. Are the two triangles mathematically similar? Show how you decide. Now, if these triangles are similar, it means all the sides are in the same ratio. It means that one is an enlargement of the other. So what I could do is I could divide each of the sides by each of the sides and see if I get the same answer. So for side 1, I could just say that is 7 divided by 2.5. What's that then? So 7 divided by 2.5, that comes out to be 2.8. Okay, side 2, that's going to be equal to 8.96 divided by 3.2. What does that come out to be? 8.96 divided by 3.2. Oh, look at that, it's also 2.8. Okay, so is the third time the charm? Let's find out. That's going to be 11.2 divided by 4 then. So 11.2 divided by 4, bonza. That also comes out to be 2.8. Okay, so are the two triangles mathematically similar? Yes. Why? Because matching sides are in the same ratio, which is 2.8. Each one is 2.8 times bigger than than its matching one. Okay. And then part B says, are these two triangles definitely congruent? Give your reason. So we've got 4 rules altogether for congruency in triangles. There's side, 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 angle, side, angle, and RHS, right angle, hypotenuse, side. Okay? So if we can show that 3 sides are the same, or if we can show that 2 sides and angle are the same, or 2 angles and a side are the same, or it's got a right angle in it, the hypotenuse match, and one other side match, then we know we've got congruent triangles. Now, can we use any of those rules here? Now, we've got all the angles marked here, and all the angles are the same. So you've got this angle matching this one, you've got this angle matching this one, and you've got this angle matching this one. Okay? So that's all well and good, but I've not got an angle, angle, angle. There's no AAA rule, is there, for congruent triangles? So that's not enough, and I can't say, I'll have to say no then in this case. No. I mean, it might be, they might be congruent, we just don't have the enough information. We need at least one side in order to know that they are congruent. Okay? So can I say that they're definitely congruent? No, I can't. And the reason is it does not meet one of the conditions of congruency, as we don't have any matching sides. 2 kilograms of carrots and 5 kilograms of potatoes cost £6.36. 3 kilograms of carrots and 2 kilograms of potatoes cost £5.25. Find the cost of 1 kilogram of carrots and the cost of 1 kilogram of potatoes. You must show your working. Okay, so this is actually just a linear simultaneous equations question. We just have to go and form the equations ourselves though here, isn't it? So the first one, 2 kilograms of carrots and 5 kilograms of potatoes cost £6.36. So writing that algebraically, if I say C is the cost of carrots and P is the cost of potatoes, then what I'm saying is 2C plus 5P is equal to 6.36. Okay? And the second equation was going to be, similarly, it's going to be 3C plus 2P, and that's equal to £5.25. Okay? Now we want to find out one of these things, so we're going to have to eliminate either P or C from our equation. I think I'm going to do P because P comes second. It's just going to be easy to write out. So I'm going to take my original equations 1 and 2, and I'm going to multiply them up so I've got the same number of carrots for each. So if I take this first one and multiply it by 3 and the second one and multiply it by 2, then that's going to give me 3 lots of 2C is 6C, 3 lots of 5P is 15P, 3 lots of £6.36. What's that calculator? 6.36 times 3. That comes out to be 1908. Okay, so that's the first one. Second one, I'm going to multiply everything by 2. So 3c times 2 is 6c, 2p times 2 is 4p, and £5.25. I can cope with that in my head, that's £10.50. Okay, so then what we're going to do is going to eliminate c by subtracting then, aren't we? So if we subtract those, take the second equation away from the first, then 6c take away 6c is no c, 15p take away 4p, that's 11p, 1908 take away £10.50, that's £8, what is it, 19, oh, don't be a hero, just type it in, £10.50, that comes to be £8.58. Okay, so 11p is £8.58, so p is going to be £8.58 divided by 11, then, isn't it? That's going to be 78 pence. Okay, so the price of potatoes is 78p a kilo. And then, now I know what p is, I can substitute that back in, can't I? I can substitute p equals 0.78 into one of my previous equations. Let's go for, I might as well go for equation 2. Okay, so then 3c plus 2 lots of 78p, well, 2 lots of 78p is £1.56, and that's equal to £5.25. So then taking £1.56 away from £5.25, £5.25 take away £1.56, that comes to £3.69. And that's 3c, isn't it? So then c, the cost of 1 kilo of carrots, is that divided by 3, and that comes out to be £1.23. £1.23. Now it's always a good idea just to double check this. I used equation 2 to work out c from p, so if I just add both those numbers, sub both those numbers into equation 1, just to double check that it all balances out. So check. So if I do 2 lots of the price we think carrots are, £1.23, plus 5 lots of the price we think potatoes are, 0.78, is that equal to £6.36? I'm just going to double check that on my calculator. 2 times 1.23 plus 5 times 0.78, that does indeed come to £6.36. Okay, so I'm happy with that. Right, so yeah, you know, it only takes a couple of minutes to do these little checks in the exams. It's better to know in the exam whether or not you're right than wait until 3 months later and it comes back with a few marks less than you need. Okay, so just take a few moments to check these things if you can. That's quite a nice check for simultaneous equations. Riley and Sam are conducting surveys. They are both given the same list of 12,463 people from which to select their sample. Riley selects every 56th person. Sam selects every 64th person. They both start counting from the first name in the list. Work out how many people will be selected to be in both surveys. You must show your working. Okay, so if I'm starting from person number 1, then and I'm doing every 56th person, how many times am I going to be able to do that then? What is 12,463 divided by 56? Okay, so if I divide that, 12463 divided by 56, that comes out to be 222.5. Okay, so that's 222 point, well, I'm going to round up to 0.6. Okay, so if I pick the first person and then I pick the 222 times 56th person, that's going to be the last person in my list, because I'm not going to get enough people then to get on to the next one, am I? So I think that rounds down to 222 people. And then for Sam, he's doing the same thing, but he's going through every 64th person. So what does that come to? So 12463 divided by 64, that comes out to be 194.7. Now again, I'm going to have to round that one down, because that 0.7, you're not going to get to anyone in the list before you get to the next 64th person. So you go beyond the end of the list, haven't you? So it's going to be 222 and 194 selected people. So then adding those together, that's 614,416. However, there's a catch, because every now and then, I guess, Riley and Sam are going to land on the same person, aren't they? Okay, if they land on the same person, they can't both have that same pick because it's the same person. So the other thing we need to do is we need to deal with any person that they both picked, and then kind of make sure we're not double counting them. Okay, so in order to do that, I think what we need to do is find the common multiples then of 56 and 64. Now to do that, they're quite big numbers. I think to find the lowest common multiple, given the fact that the numbers are quite big and close together, I'm probably going to use prime factor decomposition here. That's kind of the easiest way of doing it. So what's 56 as a product of its primes? Tapping that into the calculator. If I just type in 56 and go to format, you can see it can come down here and select prime factors. And it will just write out for me. So 56 is equal to 2 cubed times 7. And doing the same thing with 64, typing that into the calculator, then format and go into prime factors. That is 2 to the power of 6. Okay, so then the LCM of those two numbers is going to include all the bases that appear. So I've got like a 2 appearing and a 7 are appearing. So my LCM is going to have a 2 and a 7 in it. And then I'm going to pick the highest power that appears for each one of those. So I've got 2 to the 3 and 2 to the 6. So 2 to the 6 trumps 2 to the 3. So I'm going to write a 2 to the 6 in my LCM. And I've just got a 7, so I'm just going to have that 7. So the LCM then is going to be 2 to the 6 times 7, or 64 times 7. And that comes out to be 448. So that means every 448th person is someone that they both picked. Okay, now how many of those are there in 12,463? Because each one of those we've counted twice in that 416. So then we're going to do 12,463 divided by 448. That comes out to be 12,463 divided by 448. That comes out to be 27.7. So that, you know, again, so I'm going to round down in this case because the 0.7 is going to be off the end of the scale. So that means we've overcounted by 27 people. So I'm going to subtract that 27 people from the total. And then, yeah, that should be the number of people who actually are in the survey. So 416 minus 27 was 389. Now, I almost overlooked that, to be honest. I just thought I was going to work out the two numbers, add them together. But then I looked down there and I was thinking, 5 marks for that, and that looks a bit easy. So then I had another think about it, and that's when I realised, you know, there was more to it. So, yes, have a look at the number of marks, because it does give you an indication of the complexity of the problem and how much work you're likely to do. So if your problem goes very easy, just have another think about it in case you haven't kind of overlooked something. Question 26. XOY is a sector of a circle centre O. Show that the area of the sector is 15.3 centimetres squared. Correct 3 significant figures. Okay, so area of a sector. Area of sector. Now, a sector is just a slice of a circle, isn't it? It's like a pie slice of a bigger circle. You can imagine a bigger circle like this. Okay, and that's like a pie slice of it. Okay, so it's a fraction of a circle. What fraction of a circle is it? Well, if a circle has area pi r squared, so it's going to be a fraction of pi r squared. Now, what fraction of a circle do we have? Well, we know we've got an angle of 70 degrees at the center there, and we know that generally circles have 360 degrees in them, don't they? So this is going to be 70/360ths of a circle. So its area is going to be 70, the angle at the center, over 360 times the area of a circle. Now, radius, we know, is 5. It's given there, look. So then the area of this sector is going to be 70 over 360 times pi times 5 squared. Okay, and that comes out to be 70 times 25 divided by 360. Now that comes out to my calculator is 15.2716309.5, which if I then round off to three significant figures, it's going to be rounding off after those 3 digits then, isn't it? So if I then round that off, next digit along is a 7. So again, I'm going to be rounding up here. So my digits 152 are going to become 153 with a dot there in between. So look, I've shown it then. So it does come to 15.3 centimeters squared as required.
Mr. T, he's the best. Helps you ace every test. Maths worries now.